November 11, 2025. While most slept, the Nordic Optical Telescope captured the first ground-based image of interstellar comet 3I Atlas as it reappeared from behind the Sun, revealing bright concentric rings and a one-way path out of the solar system. There are 38 days left before this ancient visitor vanishes forever. But the real surprise lies in what these new images expose about its structure and chemistry. Why is this fleeting moment such a breakthrough? At 4:19 Universal Time on November 11, 2025, a small team at the Nordic Optical Telescope captured a single annotated frame that electrified the astronomical community. The comet 3I Atlas, invisible for nearly 2 weeks after swinging behind the Sun, now appeared in the pre-dawn sky, its bright coma unmistakable against the deep background. For the first time since perihelion on October 30, 2025, ground-based observers could measure its brightness, track its structure, and confirm its position. The clock started ticking. Just 38 days remain before the comet's closest approach to Earth on December 19, 2025. Every detail in this frame matters. The image released immediately to the global network and cited in Astronomers' Telegram, 17,490 is more than a snapshot. It is a scientific rallying cry. The next few weeks will define what humanity learns from this rare interstellar visitor, and the race to collect data has begun. Processed images from the Nordic Optical Telescope reveal a striking sequence of concentric rings radiating from the comet's core. At the center, a dense white nucleus anchors the structure, a compact region where ancient ices are still sublimating. Surrounding this, the magenta inner coma glows with intense gas emission, evidence of volatile materials vaporizing as sunlight strikes the surface. The cyan midzone marks a transition, where outgassing slows but remains active, while the faint green boundary traces the outermost extent of the coma, blending gradually into the darkness of space. This layered brightness gradient is not just a visual artifact. It is a physical map of energy and chemistry, sculpted by ongoing activity after billions of years in interstellar cold. Subtle elongations within the rings hint at jets of dust and gas, likely driven by the rotation of the nucleus. Each contour in these images encodes the story of a comet still alive, venting material as it races outward from the Sun. Yellow arrows on the November 11th Nordic Optical Telescope image trace two key directions. One arrow points straight from the comet core, the other points back toward the Sun. The first, labeled -V, marks the path of 3I Atlas as it speeds outward, away from solar gravity. The second, labeled -S, shows the direction of sunlight that is still driving the comet's activity. Astrometric analysis of these vectors, anchored by field stars and precise timing, leaves no room for doubt. The comet is on a hyperbolic orbit, not bound to the Sun. The measured eccentricity, E equals 6.137, stands far above the threshold for solar system objects. This number is the mathematical signature of an interstellar origin, a one-way passage that will never return. Projected forward, this outbound corridor brings 3I Atlas to its closest approach to Earth on December 19, 2025, then carries it away forever, mapped with precision by the geometry captured in this single frame. To unlock the secrets hidden in the November 11 frame, astronomers applied 4 distinct image processing techniques, each designed to isolate a different physical property of 3I Atlas. The blue-filtered image brings scattered sunlight from dust grains into sharp relief, revealing the distribution of solid particles near the nucleus. Contour mapping traces intensity levels, mapping out the coma's layered structure and the symmetry and reach of the coma. Color-enhanced processing separates gas fluorescence from dust reflection, exposing subtle chemical boundaries that would otherwise blend together. The green false color image highlights the faintest outer regions, tracing the full extent of the coma and picking out asymmetric features. Together, these methods transform a single observation into a suite of diagnostics, enabling scientists to quantify brightness, map composition, and track activity, all from the same raw data. Translating the brightness of 3I Atlas into real-world dimensions begins with a simple equation grounded in the November 11 dataset. At a geocentric distance of 1.515 astronomical units, roughly 226.7 million kilometers. Each arc second in the Nordic Optical Telescope image corresponds to 1,305 kilometers. The comet's apparent magnitude, measured at 9.7 in the V band, anchors the calculation. Assuming a standard cometary albedo of 0.04 and applying a phase correction for the 27.6-degree angle, astronomers derive a nucleus diameter bracketed between 440 meters and 5.6 kilometers. The innermost white core, unresolved in the image, sets the lower bound, while the full brightness profile, corrected for coma contribution, defines the upper. These numbers, cited directly from Astronomer's Telegram 17490, transform a patch of light into a solid, ancient object, its scale mapped precisely from calibrated photometry. A faint but distinct tail stretches away from the comet, perfectly aligned with the sun's direction, direct proof of solar radiation pushing dust from the nucleus. Spectral analysis of the processed images confirms the presence of cyanogen, diatomic carbon, and triatomic carbon, each mapped to specific regions in the false color frames. These molecules, preserved since the comet's birth around another star, now vent into space for the first and only time within reach of Earth's telescopes. The global observing community is called to action. We urge all optical and near-infrared observers worldwide to obtain photometric and spectroscopic data of 3I Atlas during the accessible post-perihelion window, beginning November 11th, 2025, and continuing through close Earth approach on December 19th, 2025. Please report reduced and raw data, with calibration details and observing geometry, to the central campaign address 3iatlas-campaign@jpl.nasa.gov as soon as possible. With just 38 days left, every observation counts. For 38 days, ancient interstellar ice glows within reach. Every observation now rewrites what we know of other worlds and reminds us, no second chances for discovery.
3I Atlas still single. Images taken by the Nordic Optical Telescope on November 11, 2025, show that 3I Atlas is still a single active object. There's no sign that it has broken apart after passing close to the Sun. The comet's surrounding cloud, called the Coma, looks uneven, with two main directions, one around 106 degrees and another around 301 degrees. The first one, near 110 degrees, points roughly toward the Sun. It's likely the same bright fan seen earlier, made of large, slow-moving dust particles released by sunlight heating the comet's surface. The second one, near 295 degrees, points away from the Sun. That's the comet's normal dust tail. Some people have spotted plasma gas structures in other wide-field images, but those don't appear here because these pictures were taken through a filter that only highlights dust, not gas. At the time of observation, 3I Atlas was 1.4, 3 times the Earth-Sun distance from the Sun, 2.16 times the Earth-Sun distance from Earth. Seen from a 22-degree angle relative to the Sun, the linked images show the comet with north at the top and east on the left, covering an area about 500,000 kilometers wide. The directions pointing away from the Sun, -S, and opposite to its motion -V, are marked. A fuzzy spot above and left of the comet is actually a galaxy, and the small bright dots are stars. The 4 image versions are normal brightness, contour map, color contour map, a filtered version that highlights fine details within 130,000 kilometers of the center. The faint diagonal line you see across the image, top left to bottom right, is an artifact called an elon.